Hey team, it's Andre from High Performance Academy here. Welcome to another one of our webinars. Just a little bit of an update on what's been going on around here over the last week. We are running another one of our giveaways, and to find our giveaways, you can always head to hpacademy.com/giveaways. We'll go to that screen in a second, but we have partnered with EMTron in Australia, and they've given us one of their KV8 ECUs. This is a very high-end motorsport grade ECU. As its name implies, designed to run 8-cylinder engines, but obviously a lot of flexibility in there. Don't necessarily need to be putting it on an 8-cylinder, but it will be able to control direct spark and sequential fuel injection on 8 cylinders, also drive-by-wire, basically all of the modern goodies that you would expect from a motorsport grade ECU. On top of this, we are also including our suite of tuning courses. This total package is over $5,500 US in value. We can head across to my laptop screen, and this is where you will come to if you head to hpacademy.com/giveaway. Maybe Sam can drop a link into the comments as well to make it super easy for you to find. So this gets our suite of tuning courses, so you're actually going to know what you're doing once you get that ECU. And doesn't really matter whereabouts in the world you are, we will ship this free of charge to your door. So don't think that you're going to miss out if you don't happen to live in New Zealand. So really, really great giveaway. If you've got a project that's being built at the moment, this is going to be a really great addition to any ECU upgrade. So get yourself into the draw. No catches here, no need to purchase anything to get into the draw. Now I wanted to do a little bit of an update on our SR86. So we are kind of in the off season here in New Zealand, Southern Hemisphere. We are in the middle of winter, and we're about 2 months away from the start of our endurance series, albeit unfortunately I'm going to actually miss the first of our 3 rounds. That being said, we still want the car back together. There was a reasonably short list of things that we needed to do to the car. One of them, which I've already talked about in one of our pre-shows, is the addition of the Bosch Motorsport ABS system, and we have partnered with Bosch Motorsport in Australia to do some pretty detailed testing around this system, and we'll be bringing out a video on that in the next couple of months once we've got the car back up and running. Really, I wanted some hard facts, some hard detail from our data on exactly what sort of improvements you can expect going from a factory-based ABS system to Bosch Motorsport ABS. I mean, we all know that Bosch Motorsport ABS is factory fitted to most of the GT3 cars and a range of other race cars for that matter. It's pretty well proven, but what does this actually mean? What does it mean for your stopping distances? What does it mean for your braking performances? What does it mean from the driver's seat? I wanted all of that data, and I wanted to bring that out. So that will be coming out as soon as we've got the car back up and running and back out on track. As part of this as well, we also wanted to do a bit of a freshen up of the engine. It's done a couple of seasons of racing now, and particularly after the last sprint series, I could hear when it was cold, getting off the trailer or back onto the trailer, cranking, I could hear that it was slightly down on compression on 1 cylinder. And we'd had this in the past with a valve seating issue, which we had addressed, or at least thought we'd addressed, but I assumed that that was probably the issue. Not really a big deal. Once it was actually up to temperature, it sounded like it was pretty even again, but definitely noticeable when it was cold. And this is kind of one of the things that you should be sort of listening for with an engine. When it's cranking, you can kind of hear how it cranks. And if you've got an engine that is down on compression on 1 cylinder in particular, you're going to hear that cranking becomes uneven. And that's a bit of a giveaway, a bit of a red flag if you like. So anyway, pulled the head off and actually found something I totally wasn't expecting to find, which is a problem with number 4 piston. Now, I'll show you here, but it's probably going to be pretty hard to see. There's actually a crack through the crown of the piston. But again, pretty hard to probably see like this. So let's dive into my laptop and I'll show you in a bit more detail. Yes, I have got that turned on. So this is the crack that we can see right here. And it's definitely came as a bit of a surprise. First of all, this is a crack that obviously goes straight through the crown. And the fact that I could only barely audibly hear that we're a little bit down on compression was pretty surprising given the nature of this crack. I also straight away went back and had a look over my data because we do monitor crankcase pressure in this engine. And it really wasn't even noticeable from the crankcase pressure trace. If anything, it was maybe up about 2 kPa, but I mean, that's as good as a day-to-day variation realistically. So nothing really obvious there. Interestingly, the last time it was on the dyno just before the last event, it was also still making north of 600 wheel horsepower. This is a really, really narrow miss. We were probably laps away from this piston becoming a two-piece piston. And when that would happen, the piston's going to break in half and the con rod's going to throw itself out through the side of the block. Basically a full catastrophic failure. And in that situation, it would probably be really, really hard given the destruction that would entail to really sort of reverse engineer that and figure out what had happened. So anyway, let's go through a few more of these photos. So this is a bit of a zoom in on that crack, and we can actually see that the crack is sort of also propagated through to the edge of the piston, and it's run down the ringlands as well. This bit here is where it actually goes right through the crown. I can only imagine that this was probably expanding and mostly sealing when it was actually at operating temperature, which is why it was still making great power and why we didn't hear the low compression when it was at operating temperature, and also why we weren't seeing the crankcase pressure increase. Looking at this as well, you can see that the crack actually runs right through the pin boss and down through the side of the piston. So again, very, very narrow escape. Also visible in this, you can see quite a bit of wear in the pin boss, which kind of leads us into what we'll be talking about in a second. This is that particular piston, and this is actually where that crack has started from. It's actually begun in this radius between the underside of the crown and the pin boss, and then it's propagated right the way through on number 4 piston. The reason I say it started here is because the other 3 pistons have no sign of any damage on the crown, but they do show signs, which we'll see in a second, of cracking starting in that exact same area. So here you can sort of see little crack running through here. Basically, yeah, again, the piston's just about to fall to pieces. This is before anyone jumps to conclusions as well. Absolutely not a knock or detonation related failure. And to prove that, what we're looking for with knock detonation, you're going to end up with a sandblasted appearance, at least initially, in this area here of the crown. So around the edges, generally it actually happens around the edge of the piston on the intake valve side. That sandblasted appearance, and if it gets a little bit more severe, it'll actually melt fully, but that sandblasted appearance would be a hint that detonation is occurring. In this instance, it would be very difficult, but not quite impossible for the engine to be detonating. We're running on an E85 fuel. We're only running relatively moderate boost, around 24 PSI on high boost. Actually, the engine runs most of the time at about 15 to 16 PSI for the endurance racing. And at that point, even with the conservative timing that we've got, if I was to lean on this and tune it to MBT timing, which I've purposely not done, there's just almost no chance of knock occurring at that sort of power level and boost level. So, let's carry on. So this is what we're seeing on the other 3 pistons here. So just that sign that the cracking has just begun. Cylinder 1 was very, very mild. Cylinder 2 and 3 we're looking about like what we've got here. So obviously a little disturbing and a little bit concerning that we've got into that situation. Under these conditions, what we want to obviously do is figure out why this has happened so we can make sure that it doesn't happen again. And these pistons are CP pistons, before anyone asks. And I went back to CP, some photos, and basically they came back and said that the wrist pin that we're using, which admittedly is just an off-the-shelf wrist pin. This wasn't an upgraded wrist pin. Like a lot of projects, this engine was never really intended to run at the power levels we're currently running it on high boost. When we first built it, everything's sort of kind of blown a little bit out of proportion from where we started. So if I was to have my time again, I probably would have spec'd a upgraded upgraded wrist pin, and the upgraded wrist pin uses a combination of a superior steel alloy material, something that's physically stronger, as well as a thicker wall. Now, what CP have basically told me is that this wrist pin is flexing due to the cylinder pressure, and that flex is then being transferred into the pin bosses. Now, that also does account for some of the wear that we're seeing in the pin boss, and basically what it's doing is making the piston flex through the wrist pin bosses, and that flex is then resulting in the cracking that we're starting to see. All well and good. I mean, initially, I was sort of thinking to myself, well, yes, we didn't spec these pistons initially for sort of 650 wheel horsepower, so fair play. The reality is, though, we've run the engine at a very, very limited amount on that sort of boost level, and the majority of the running has been done around 450 to 500 wheel horsepower, which I absolutely believe that just about any quality forged piston should be able to handle. So, yeah, the wrist pin would be an upgrade. I posted some of this on my personal Instagram over the weekend, and I had a few people that are in the industry reach out to me and basically said they've seen the same issues with CP pistons cracking, and I don't really want to repeat that. We actually moved to the CP. I've got nothing against them, I should be clear. We moved to the CP from JEs that were originally in the engine due to a very early failure that we had due to a blocked injector, and we had a very tight time frame, couldn't get a replacement JE, and ended up using the CPs. And I mean, they made great power, really nothing untoward until I pulled this down. But just to show you a comparison, side by side, the JE with the CP. And what we can see with the CP, this is quite an old design realistically. JE went away from this, what is called a full round piston skirt, quite a while ago. And the JE piston I'm holding in this hand here, this uses JE's what they call an FSR, a forged side relief skirt. So let's just get rid of this one for a moment. This is asymmetric, which is pretty clear. We can see the skirt here this is on the non-thrust side, so it doesn't really need to be as wide to support the piston. On the thrust side, which is more loaded, we've got a much wider skirt. So the advantage here is that it reduces the frictional losses of the piston. We don't have as much skirt essentially in contact with the oil film on the cylinder wall. The other element though is if we look at how the pin boss is actually supported, the struts here, as you can see, sort of support the wrist pin boss much better than if we get the CP back into shot there. The CP, the skirt comes right around the edge of the pin boss, so a lot more prone to flex, which it sounds or looks to me like that's exactly what's happening. Interestingly, again, talking to CP, they have moved to a boxed forging, as they call it. I haven't seen one. I'm going to guess it probably looks a lot more like the JE style, but unfortunately they don't offer that for the VE cylinder head. There's differences between the VE cylinder head and the conventional DET or DE head. So we can't use a DET piston with the VVL cylinder head. Custom is 6 to 7 weeks, so that's not going to be workable. So at the moment we've got two solutions. I'm trying to see if we can get a set of shelf stock JE pistons with that forged side relief style. We'll go to those, or alternatively I'll have no option but to go with an upgraded and DLC coated pin in the CP pistons. I've got a new set sitting here on the shelf we had for a spare engine. So we'll see what happens there, but these are some considerations, and not everything is made equal, and unfortunately sometimes it takes running an engine to actually pull it down and find out where the potential weak points are and what maybe needs to be upgraded. Moving on, I also wanted to just cover off one of the upgrades that's going on at the same time in our CRX, which is also getting prepped for the endurance racing season. We've got a mountain of work actually on this car, and I'm hoping that we haven't bitten off more than we can chew. I've already covered some of the upgrades that we are going through. One of the things was moving the engine back to help improve the weight distribution, get the engine as far back as we can in the car, which was made possible because we're moving to a floor mounted pedal box that gets the master cylinders out of the way where they were mounted on the firewall, basically limiting how far we can move the cylinder head back. So we've moved the engine back a fair way, but this also requires a custom subframe. There's quite a bit of work. We were going to do this anyway because the EFCRX chassis is incredibly light, but once you actually start racing one, you realize that the reason they're incredibly light is essentially all of the steelwork is paper thin. Probably not an issue for a street car, but once you start pulling 1.5 G through corners, bouncing off curbs, and basically beating up on the thing on a racetrack, quickly you start to see the thin chassis show its limitations, and this is because we had a bunch of cracks occurring everywhere. And the cross member, even from the guy we bought it from, was basically considered a consumable. He was replacing the cross member once a season. When we finished last season, it was just about split in two. So we wanted to avoid that, and we're going to go to a tubular chromoly subframe. We were doing that, as I say, anyway, but this sort of forced our arm on that because we really didn't have any way of moving that engine back without the custom cross member. So Connor, who works here at HPA and has recently released his 3D modeling and CAD course, that's his specialty, has been busy. So I'll jump across to my laptop screen. Fortunately, we bought a Peel 3D scanner a while back, and we thought it was going to be useful, but it's actually come in very, very handy, and it's been used almost constantly since we've got it. So Connor and Brandon basically scanned the entire front end of the car. That allowed them to locate the engine, and we're also going to be using that. This shot has the Hollinger SF transmission in location. Hollinger gave us a 3D model of that. We're going to be using that to help set up the axle length. But as part of that, Connor also managed to relocate the steering column and design around this tubular cross member. So this picks up from a couple of places here on each side of the car. It also incorporates the caster control arm, which we can see here. And it also incorporates new mounts for the lower control arm. Obviously, that lower control arm itself is also going to be new. The rest of the suspension is essentially existing. So this basically allows Connor to design in the virtual world, make sure that everything is going to clear. Things that we need to consider is clearance, particularly around the exhaust manifold. We didn't want to have to make a new exhaust manifold. We've already got enough work on our hands without needing to do that. And basically make sure that everything's going to work how we expect before we actually go and make anything. So this particular task is going to be covered in a couple of our courses. It's going to be covered in our motorsport fabrication course. It's going to be covered in our practical TIG welding course because, of course, it will be a chromoly subframe and it will be TIG welded. TIG welding a chromoly as well needs to be treated with a bit of care, particularly around the fit up. We need really, really good fit up with the notching. You do not want to be basically trying to fill gaps when you are TIG welding chromoly because that will put more heat into the material. And chromoly is very sensitive to heat. What you'll essentially get is a heat affected zone which becomes very brittle, and it's quite common with chromoly, particularly chromoly cages, if they haven't been welded properly with the right attention to detail, that they will actually crack beside the weld and they can be quite dangerous. Obviously we don't want that, so we'll be covering that in the CAD course as well as the practical TIG welding course as well. So yeah, just a little bit of an update on what is going on there. Just give me a second to go back to my notes here. Actually, while I'm talking about the Motorsport CAD course as well, just if we head across to my laptop screen, we'll just quickly run through this. Course is $199 US. If you are interested in learning the skills of CAD and solid 3D modeling for motorsport applications, this is the course for you. I'll just quickly cover off. It covers the basics of CAD, essentially what it is, design fundamentals, because while it isn't an engineering course, it is important when you are designing components for a car to have at least a broad understanding of what forces are involved so you can essentially make sure that the parts are going to be fit for purpose. Connor then covers some of the solid modeling basics like datums, 2D and 3D sketching, extrudes and holes, revolves, etc. Sheet metal modeling basics. And even if you aren't really interested in 3D modeling, the sheet metal tools in the likes of SolidWorks or Fusion 360, any of the other programs essentially, have become really, really valuable. I wish I had access to this back when I was building my old drag car, because now you can basically design a part and then essentially create a template, either cut that out yourself or better still send it to a company like Send Cut Send, and they will laser cut the part, even fold it for you and send it back. So you can start getting some really professional looking parts, really, really advanced for really not a lot of money as well. Also moving to assemblies, analysis, post-processing of your parts, some of the more advanced CAD such as surface modeling, simulation and finite element analysis, generative design and automated modeling. 3D scanning and printing is covered in here as well. I mentioned our Peel 3D scanner. Now, there is a price tag that comes along with even the lower spec 3D scanners. We happened to pick that one up secondhand, which was definitely a big advantage. But these days, if you're using a phone with face recognition, then you can actually use your cell phone for some basic scanning as well. Obviously, the accuracy is not going to be as good as a professional laser scanner, but for a lot of purposes, it's absolutely fine. We've got a 5-step CAD design process that you can apply to your own job, and this will make sure that you go through everything in a step-by-step process, making sure you don't overlook anything or omit any steps that are going to be really critical. And then we've got our worked example library. This is a reasonably recent course. At the moment, we've got one worked example, which is a battery box for the particular car I'm actually sitting in. Obviously, the CRX subframe is going to go in here as well. We've also got just about to be added to this, the process of designing and manufacturing a billet rocker cover for our SR20. So if you want to check that out, you can head to hbacademy.com/courses. The course is $199 US. There is a payment plan. You can break that down to make it a little bit more affordable. And as with all of our courses, 60-day, no questions asked, money back guarantee. So if you purchase and decide it's not quite what you expected, not right for you, no worries. Let us know. We'll give you a full refund of the purchase price. Right. I also wanted to talk about the podcast episode that launched last Friday. This is actually one of my favorite chats so far. It is the longest by far. I think it's around about 2 hours in length. It is super tech heavy. I know it's not going to be for everyone, but for the tech nerds out there, particularly those who like to understand the inner workings of an engine, particularly under high boost applications, this is going to be great. I'll head across to my laptop screen. So we're talking here with Ben Diggles. Interestingly, Ben doesn't work in the automotive industry. He's actually a fish doctor of all things, but he is still one of the smartest guys I know when it comes to engine design and tuning. And he's been a long-term friend of mine for probably the last 20 plus years. So this particular picture here is essentially what we're talking about in this podcast, abnormal combustion. The hole punch through the side of this piston here is as a result of pre-ignition in a very high boost, very high power methanol drag engine. Oops, let's try not doing that. This is one of the cars Ben used to own back in New Zealand that I actually helped him with through my old workshop. It's a Nissan S12 Gazelle. It still, I believe, holds the record as the fastest Gazelle on the quarter mile. He's also involved with building some historic race engines for very, very expensive and rare Nissan race cars over in Australia. And his particular interest is the FJ20 turbo engine. He wanted to see what these were capable of and actually ended up putting one in a rear engine dragster, which is right here. It ran into the high sixes, but basically once he started pushing the engine to its limit, found that the abnormal combustion or some of the problems around the cylinder head design, the engine design really were limiting it when he got to that point. So again, if you are interested in the inner workings of an engine at that sort of boost level, this is going to be the podcast for you. You can check it out anywhere you listen to podcasts now. Just search for HPA Tuned In or head to tunedin.com, which will take you to this page right here, hpa-tunedin.com. You can find all of our episodes. Subscribe. Also, if you are listening to our podcast, I would really appreciate it if you could leave us a rating and a review. These really help us to grow the podcast and get more high quality guests, which means that everyone benefits. And as a added bonus, just to say thanks, we will be picking one random reviewer every week, and we will be sending out a free t-shirt to you if your review gets picked anywhere in the world free of charge. So please go ahead and give us a rating and a review. Right, we'll finish off just by a reminder here, our EMTron KV8 giveaway plus our HPA tuning suite package, $5,500 US worth of value. Really, really great prize, probably one of the more valuable prize packages we have given away. And you can head to hpacademy.com/giveaway and get your name into the draw. Remember, absolutely no catches. I think there's about 22 days left for that to run, so don't miss out. Right, give me a moment here and we'll get started with today's lesson.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.